OffLecture. Learn beyond class.
Every day, your inbox silently swats away junk mail you've never received before. It hasn't seen that exact combination of words or that specific sender, yet somehow it knows exactly what to do with it. The secret lies in what happens before the filter ever goes live. Long before it touches your personal inbox, it studies a large archive of old mail. Human reviewers pre-sorted this archive into strict categories, spam or not spam. That mountain of previously sorted examples provides the filter's skill. The question is, how does a machine translate a static pile of old answers into the ability to handle brand new problems it's never encountered? This process is called supervised learning. It's a method of training a machine using examples that have the correct answers securely attached to them. Think of a child studying with a deck of flashcards. The raw data, the question, is on the front, and the label, the answer, is written on the back. The machine flips through millions of these digital flashcards at lightning speed, hunting for the mathematical relationship between the data on the front and the answer on the back. To find that relationship, it relies on a three-step loop. First, the machine makes a preliminary guess. Second, it checks its guess against the true label. Third, it mathematically adjusts its parameters to shrink the difference. A single adjustment alone barely changes anything, but repeat that exact sequence of guess, check, and adjust thousands of times, and the system transforms from a random guesser into a highly accurate predictive engine. This diagram illustrates a visual dataset. Feed the model 1,000 explicitly labeled photos of a cat or dog, and the loop goes to work. It stops seeing whole animals, instead isolating specific repeating patterns tied to tags, like sharp triangular ears or linear whiskers. Now for the real test. We present the fully trained model with a brand new, completely unlabeled image of a puppy. It cross-references the fresh image against its internal map of learned patterns. The shapes align, and it correctly outputs dog. This is the inductive leap. The system has synthesized a universal rule from specific examples to navigate a future it hasn't seen. But this system has a major vulnerability. The AI possesses exactly zero common sense. It relies entirely on the absolute truth of its training labels. If human labelers provide sloppy, incorrect, or biased answers on those digital flashcards, the model will faithfully, confidently learn the wrong logic. The model depends entirely on the quality of these labels. Even an advanced system will fail if its training data is flawed. This curation process drives much of the software we use daily, from medical scan diagnoses to financial fraud alerts and photo tagging. You can actually step into the role of the supervisor and prove this concept yourself, right in your own inbox. Gather 20 of your own emails and definitively sort them into spam or not spam. You are creating your own teaching set. Then, look at 5 completely unread emails. Test the mental patterns you just established against those fresh messages. By physically replicating this pipeline, you see that AI functions as a direct reflection of human instruction, something you can actively understand and control.